Hello YouTube! Today I want to talk about nanotechnology. I pulled up nanotechnology on Wikipedia and now I'm just going to read what it says. It says nanotechnology from Wikipedia, the free encyclopedia. From Material Science Journal, see Nanotechnology Journal. Nanotechnology, sometimes shortened to nanotech, is the manipulation of matter on an atomic and molecular scale. The earliest widespread description of nanotechnology referred to the particular technology goal of precisely manipulating atoms and molecules for fabrication of macro-scale products, also now referred to as molecular nanotechnology. A more generalized description of nanotechnology was subsequently established by the National Nanotechnology Initiative, which defines nanotechnology as a manipulation of matter with at least one dimension sized from 1 to 100 nanometers. This definition reflects the fact that quantum mechanical effects are important at this quantum realm scale, and so the definition shifted from a particular nanotechnological goal to a research category inclusive of all types of research and technologies that deal with the special properties of matter that occur below the given size threshold. It is therefore common to see the plural form nanotechnologies as well as nanoscale technologies to refer to the broad range of research and applications whose common trait is size. Because of the variety of potential applications, including industrial and military, governments have invested billions of dollars in nanotechnology research. Through its National Nanotechnology Initiative, the USA has invested $3.7 billion. The European Union has invested $1.2 and Japan $750 million. Nanotechnology, as defined by size, is naturally very broad, including fields of science as diverse as surface science, organic chemistry, molecular biology, semiconductor physics, microfabrication, etc. The associated research and applications are equally diverse, ranging from extensions of conventional device physics to completely new approaches based on molecular self-assembly, from developing new materials with dimensions on the nanoscale to direct control of matter on the atomic scale. Scientists currently debate the future implications of nanotechnology. Nanotechnology may be able to create many new materials and devices with a vast range of applications, such as medicine, electronics, biomaterials, and energy production. On the other hand, nanotechnology raises many of the same issues as any new technology, including concerns about the toxicity and environmental impact of nanomaterials and their potential effects on the global economic, as well as speculation about various doomsday scenarios. These concerns have led to a debate among advocacy groups and governments on whether special regulation of nanotechnology is warranted. Here, under Origins, it says the concepts that seeded nanotechnology were first discussed in 1959 by renowned physicist Richard Feynman in his talk "The Plenty of Room at the Bottom," in which he described the possibilities of synthesis via direct manipulation of atoms. The term nanotechnology was first used by Norio Taniguchi in 1974, though it was not widely known. Inspired by Feynman's concept, K. Eric Drexler independently used the term nanotechnology in his 1986 book Engines of Creation, The Coming Era of Nanotechnology, which proposed the idea of nanoscale assembler, which would be able to build a copy of itself and of other items of arbitrary complexity with atomic control. Also in 1986, Drexler co-founded the Foresight Institute, with which he is no longer affiliated, to help increase public awareness and understanding of nanotechnology concepts and implications. Thus, emergence of nanotechnology as a field in the 1980s occurred through convergence of Drexler's theoretical and public work, which developed and popularized a conceptual framework for nanotechnology, and high-visibility experimental advances that drew additional wide-scale attention to the prospects of atomic control of matter. For example, the invention of a scanning tunnel microscope in 1981 provided unprecedented visualization of individual atoms and bonds, and was successfully used to manipulate individual atoms in 1989. The microscope's developer Gerd Braining and Henrik Roeder at IBM Zurich Research Laboratory received a Nobel Prize in Physics in 1986. Binning, Quate, and Gerber also invented the analogous atomic force microscope that year. Fullerenes were discovered in 1985 by Harry Kroto, Richard Smalley, and Robert Curl, who together won the 1996 Nobel Prize in Chemistry. C60 was not initially described as nanotechnology. The term was used regarding subsequent work with related graphene tubes called carbon nanotubes and sometimes called Bucky tubes, which suggested potential applications for nanoscale electronics and devices. In the early 2000s, the field garnered increased scientific, political, and commercial attention that led to both controversy and progress. Controversies emerged regarding the definition and potential implications of nanotechnologies, exemplified by the Royal Society's report on nanotechnology. Challenges were raised regarding the feasibility of applications envisioned by advocates of molecular nanotechnology, which culminated in a public debate between Drexler and Smalley in 2001 and 2003. Meanwhile, commercialization of products based on advancements in nanoscale technologies began emerging. These products are limited to bulk applications of nanomaterials and do not involve atomic control of matter. Some examples include the Silver Nano platform for using silver nanoparticles as an antibacterial agent, nanoparticle-based transparent sunscreens, and carbon nanotubes for stain-resistant textiles. Government moved to promote and fund research into nanotechnology, beginning in the U.S. with the National Nanotechnology Initiative, which formalized a size-based definition of nanotechnology and established funding for research on the nanoscale. By the mid-2000s, new and serious scientific attention began to flourish. Projects emerged to produce nanotechnology roadmaps which center on atomically precise manipulation of matter and discuss existing and projected capabilities, goals, and applications. Well, there goes a lot of information on nanotechnology and its origins. And I mean, really, I'm excited to see how this field of science will continue to grow. I'm really excited to see where it goes. Because nanotechnology can be used in medicine to really help the sick, and that is a great advancement in science whenever nanotechnology will be able to be used in medicine to help sick people. And that's how I think the best use of nanotechnology is for our health. But this video is going on 10 minutes now, so I'm going to go ahead and stop it. It was nice making a video again today on June 6, 2013, Thursday.